Download this code from codegive.com, link in the description below. OK, let's delve into the world of cross-site scripting, XSS, attacks, exploring their types, impact, and most importantly, comprehensive countermeasures with code examples in various languages. This will be a long and detailed guide, so buckle up. What is cross-site scripting, XSS? Cross-site scripting, XSS, is a type of web security vulnerability that allows attackers to inject malicious scripts into web pages viewed by other users. Essentially, it exploits the trust that users have in a particular website, leading them to execute code that was not intended by the web application developer. Why is XSS a problem? XSS can have severe consequences, including account hijacking. An attacker can steal a user's session cookie and impersonate them. Data theft. Sensitive data, like passwords, credit card information, or personal details, can be stolen. Website defacement. An attacker can alter the content of a website. Malware distribution. XSS can be used to redirect users to malicious websites that install malware. Keylogging. Attacker can install a keylogger to record user keystrokes. Phishing. Displaying a fake login page on the genuine website. Redirection. Redirection to a malicious domain. Types of XSS attacks. There are three main types of XSS attacks. 1. Reflected XSS, non-persistent XSS. How it works. The malicious script is embedded in a URL or submitted as part of a form. When the server receives the request, it includes the script in the response without properly sanitizing or escaping it. The user's browser then executes the malicious script because it originated from a trusted source. Example. A search functionality that displays the search term on the page. If the search term is not properly escaped, an attacker could craft a URL like this. The server might output. The browser would then execute the alert, XSS, script. Characteristics. The malicious script is part of the request. The server doesn't permanently store the script. The user has to be tricked into clicking a malicious link or submitting a form containing the script. 2. Stored XSS, persistent XSS. How it works. The malicious script is stored on the target server, such as in a database, forum post, comment section, or user profile. When other users access the stored data, the script is executed in their browsers. Example. A forum where users can post messages. If the forum doesn't sanitize user input, an attacker could post a message like this. Every time someone views that forum post, the malicious script would execute. Characteristics. The malicious script is stored on the server. It affects all users who view the affected content. Stored XSS is generally considered more dangerous than reflected XSS because it doesn't require tricking users into clicking a link. 3. DOM-based XSS. How it works. The vulnerability exists in the client-side JavaScript code itself. The malicious script is injected into the DOM, document object model, of the page, often through manipulating the URL fragment, the referrer, or other client-side data sources. The server doesn't need to be involved in the injection, making it harder to detect on the server side. Example. If the URL is, the search term variable will contain imgsrc equals x1 error equals alert, XSS, and the inner HTML assignment will inject the script into the DOM. Characteristics. Asterisk the attack is entirely client-side. Asterisk the server might not be aware of the vulnerability. Asterisk DOM-based XSS vulnerabilities can be difficult to identify because they don't involve server-side processing of the malicious input. Countermeasures for XSS. Preventing XSS vulnerabilities is crucial for web application security. Here are the main countermeasures. 1. Input validation asterisk. Asterisk what it is asterisk validate all user inputs to ensure they conform to the expected format and data type. Reject or sanitize inputs that are invalid or contain unexpected characters. Asterisk how to do it asterisk. Asterisk whitelisting asterisk define a set of allowed characters or patterns and reject anything that doesn't match. This is generally the most secure approach. Asterisk blacklisting asterisk define a set of disallowed characters or patterns and remove or escape them. This is less secure than whitelisting, as attackers can often find ways to bypass blacklists. Asterisk data type validation asterisk ensure that data is of the expected type, example integer, email address, URL. Asterisk length limits asterisk restrict the length of user input to prevent buffer overflows or excessively long strings. Asterisk code examples asterisk. Asterisk PHP, whitelisting. Asterisk Python, using remodule for whitelisting. Asterisk JavaScript, client-side, for basic validation. Remember that client-side validation is not a substitute for server-side validation. 2. Output encoding / escaping asterisk. Asterisk what it is asterisk convert potentially harmful characters into their safe HTML entities or JavaScript escape sequences before displaying them on the page. This prevents the browser from interpreting them as code. Crucially, the encoding method must match the context where the data is being used. Asterisk context-aware encoding asterisk. Asterisk HTML context asterisk use HTML entity encoding, example and LT, for, and GT, for, and AMP, for and quote, for. Asterisk URL context asterisk use URL encoding, example %24 space, %3c4. Asterisk JavaScript context asterisk use JavaScript escaping, example \4 single quote, \4 double quote, \4 \. Asterisk CSS context asterisk CSS escaping is required for dynamically generated CSS. Asterisk how to do it asterisk. Asterisk use built-in functions provided by your programming language or framework. Asterisk use templating engines that automatically escape output. Asterisk code examples asterisk. Asterisk PHP, HTML entity encoding. Asterisk Python, using HTML module. Asterisk JavaScript, HTML entity encoding, browser native. Asterisk JavaScript, escaping for JavaScript context. Asterisk C, ASP.NET. Asterisk Java, using ESAPI, encoder. Make sure you have the ESAPI library in your project's class path. You can download it from the OWASP website. Important notes on encoding asterisk. Asterisk double encoding is dangerous asterisk avoid double encoding, encoding something twice. It can introduce vulnerabilities. Asterisk use the correct encoding for the context asterisk HTML encoding is different from URL encoding, which is different from JavaScript escaping. Using the wrong encoding will not protect against XSS. Asterisk always specify character encoding asterisk always specify the character encoding, example UTF-8, when encoding and decoding strings to avoid unexpected behavior. Asterisk encoding at the right time asterisk encode right before you output the data. Encoding earlier can cause issues if you need to manipulate the data later. 3. Content Security Policy, CSP. What it is. A powerful HTTP response header that allows you to control the resources, scripts, style sheets, images, etc., that the browser is allowed to load for a particular page. It's like a whitelist for resources. How it works. You specify a policy that defines the sources from which the browser is allowed to load resources. If the browser encounters a resource that violates the policy, it will block the resource from loading. Example. Default src self, by default, only load resources from the same origin, the same protocol, domain, and port. Script src self unsafe inline unsafe eval, allow scripts from the same origin, inline scripts, scripts within script tags, and dynamic code evaluation, example eval. Unsafe inline and unsafe eval should be avoided if possible, as they can weaken CSP. You can use nonces or hashes to allow specific inline scripts. Img src self data, allow images from the same origin and data URIs, used for embedding images directly in HTML. Style src self unsafe inline, allow style sheets from the same origin and inline styles, styles within style tags or style attributes. Unsafe inline is generally safe for static websites where the contents of a website are not controlled by the user. Implementation. Set the content security policy HTTP header in your web server configuration or in your application code. Example, setting CSP header in PHP. Important considerations. Start with a restrictive policy. Gradually loosen the policy as needed. Test your CSP. Use the content security policy report only header to test your policy without breaking the website. The browser will report violations to a specified URI. Report URI. Set up a report URI to receive reports of CSP violations. This can help you identify and fix CSP issues. Nonces and hashes for inline scripts. Nonce a random string generated for each page request. Add the nonce to the script tag and include it in the CSP. Hash a cryptographic hash of the script content. Include the hash in the CSP. CSP is not a silver bullet. It is a defense in-depth measure. You should still implement input validation and output encoding. 4. Use a framework with built-in XSS protection. Many modern web frameworks, example React, Angular, Vue.js, Ruby on Rails, Django, Laravel, have built-in mechanisms to help prevent XSS vulnerabilities. Templating engines. Most frameworks use templating engines that automatically escape output by default. This reduces the risk of accidentally introducing XSS vulnerabilities. Security libraries. Frameworks often provide security libraries or helpers that make it easier to implement input validation and output encoding. Regular security updates. Keep your framework and its dependencies up to date to benefit from the latest security patches. 5. HTTP only cookie attribute. What it is. The HTTP only attribute tells the browser to prevent client-side scripts, example JavaScript, from accessing the cookie. This mitigates the risk of an attacker stealing session cookies using XSS. How to set it. Set the HTTP only attribute when setting the cookie in your application code. Example, PHP. Example, JavaScript. Setting HTTP only cookies is not possible from JavaScript. You cannot set HTTP only cookies directly from JavaScript. HTTP only cookies must be set by the server. This is a security feature to prevent client-side scripts from tampering with sensitive cookies. 6. Subresource integrity, SRI. What it is? A security feature that allows browsers to verify that files fetched from a CDN, content delivery network, or other third-party sources haven't been tampered with. You provide a cryptographic hash of the expected file content, and the browser compares the hash of the fetched file to the expected hash. If the hashes don't match, the browser will block the file from loading. This can help prevent attacks where an attacker compromises a CDN and injects malicious code into the files it serves. How it works. You generate a cryptographic hash, example SHA-256, SHA-384, SHA-512, of the file. Then, you add the integrity attribute to the script or link tag, specifying the hash. Example integrity equals SHA-384 jQuery hash. Here, specifies the SHA-384 hash of the jQuery.minjs file. Cross origin equals anonymous. This attribute is required when using SRI with resources from a different origin, CDN. It tells the browser to make a cross-origin request without sending credentials, cookies, etc. The server must also send the correct CORS headers. 7. Escaping untrusted data in DOM-based XSS scenarios. Text content instead of inner HTML. When inserting untrusted data into the DOM, use text content instead of inner HTML. Text content treats the input as plain text, preventing the browser from interpreting HTML tags or JavaScript code. Avoid dynamic code execution. Avoid using functions like eval, set timeout, set interval, and function, with untrusted data. These functions allow you to execute arbitrary code, which can be exploited by attackers. Use safer alternatives, such as passing function references directly or using add-event-listener, to attach event handlers. Sanitize URLs. When using untrusted data in URLs, validate and sanitize the URL to prevent JavaScript execution. 8. Regular security audits and penetration testing. Security audits. Conduct regular security audits of your web application to identify potential vulnerabilities, including XSS. Penetration testing. Hire a professional penetration tester to simulate real-world attacks and identify security weaknesses. 9. Educate developers. Security awareness training. Provide developers with security awareness training on XSS vulnerabilities and how to prevent them. Secure coding practices. Promote secure coding practices throughout the development life cycle. Code reviews. Conduct code reviews to identify potential security issues. Summary of best practices. Treat all user input as untrusted. Validate input on the server side. Client side validation is not sufficient. Encode output appropriately for the context, HTML, URL, JavaScript, CSS. Use content security policy, CSP, to restrict the resources that the browser is allowed to load. Set the HTTP only attribute on cookies. Use subresource integrity, SRI, to verify the integrity of files from CDNs. Avoid dynamic code execution with untrusted data. Use text content instead of inner HTML when inserting untrusted data into the DOM. Conduct regular security audits and penetration testing. Educate developers about XSS vulnerabilities and prevention techniques. Use a framework with built-in XSS protection. Keep your framework and dependencies up to date. Example demonstrating the usage of multiple techniques in conjunction. Here's a combined example using PHP, HTML encoding, and CSP to demonstrate a defense in-depth approach. Explanation *. 1. Input validation. Sanitize_input. The sanitize_input function validates the user input, allowing only alphanumeric characters, spaces, and some safe punctuation marks. This helps prevent the injection of malicious scripts. Any invalid characters are removed. 2. HTML encoding. HTML special cars. The HTML special cars function encodes the sanitized input, converting characters like and into their HTML entities, and LT, and GT, end quote. This prevents the browser from interpreting them as HTML tags or JavaScript code. The end_quotes flag ensures that both single and double quotes are encoded. Always specify the character encoding, UTF-8, to avoid character encoding issues. 3. CSP header *. The content security policy header restricts the resources that the browser is allowed to load. In this example, default src self only allows resources from the same origin. Script src none completely disables inline scripts and external script files. This is a very strict policy that can significantly reduce the risk of XSS. Object src none prevents loading of plugins like Flash. Style src self unsafe inline allows inline styles and style sheets from the same origin. The unsafe inline directive allows inline styles, which might be necessary, but adds some risk. If your CSS is completely separate from the user's control, then this can be considered okay. Base URI self limits the base URL that can be used by the document. Frame ancestors self prevents clickjacking attacks by limiting the domains that can embed the page in an iframe. Form action self limits the URLs to which forms can be submitted. Why this is a good approach defense in-depth This example uses multiple layers of security to protect against XSS. Even if one layer fails, the other layers can still provide protection. Prevents execution of malicious scripts. The combination of input validation, output encoding, and CSP makes it very difficult for an attacker to inject and execute malicious scripts. Reduces the attack surface. CSP limits the attack surface by restricting the resources that the browser is allowed to load. Remember that this is a simplified example. You may need to adjust the CSP and input validation rules to fit the specific needs of your application. Thorough testing is essential to ensure that your security measures are effective. This has been a long and comprehensive overview of XSS and its countermeasures. I hope this helps you build more secure web applications. Let me know if you have any more questions.